Good morning, third graders. Today we are on page 199 of your student journal, and we are starting a new unit. We are on Unit 12, Lesson 11. Our objective today is, today I will draw scaled pictographs to represent data, period. Okay, so let's talk about some of those words. So a pictograph is just a graph that usually involves some sort of picture. Now, it doesn't always involve like a really exciting picture. If you notice this picture graph that they give us as an example, the picture is check marks. Sometimes when you were younger, maybe in kindergarten, you might have seen picture graphs where they do like little bear faces or something a little bit more exciting. And we're going to see some with smiley faces. But it's not always going to have actual pictures. So it's often has symbols instead. So up here in our definition it says, pictograph or pictograph is a graph that uses pictures or symbols to represent data. The older you get, you're going to go more from pictures into the symbols. So when the pictures or symbols represent more than one vote, it's called a scaled pictograph. So that's where the scaled part of our goal comes in, So it says we're going to draw scaled pictographs because each of our symbols or pictures is going to represent more than one thing. So if we look at this example pictograph, what we see from this is it says that the title is favorite pets. It says dogs, cats, and fish. These are our categories, but here's the scale right here. It says each check mark doesn't equal one vote, it represents or equals 5 votes. This is also called the key, where it tells you how to read it. So our scale is the value of each picture or symbol, which is given in the graph's key. Okay, so what that means is that if I just look at this quickly, I think that only 2 people had dogs as their favorite pet. But that's not what this says. Each of these check marks means 5 votes. So actually, dogs had a total of 10 votes because 5 and another 5 would be 10. Cats, again, it looks like they had 3 votes, but it actually had 3 votes, 3 check marks, which each represent 5 votes. So 5, another 5 would be 15 votes. And then fish had 1 check mark, which means 5 votes. So the reason they use this scale sometimes is just to have less actual symbols or pictures. Now, it's nice to choose a scale where you could draw the entire picture and it will still work. So sometimes you have to think about what would be the best scale. When we do some today, you're going to see where it's a little tricky when the scales aren't perfect. Okay, so our steps today are we're going to read or gather our data, find an appropriate scale for your data. And we'll talk a lot about this because I think this is one of the trickier ones. And then we're going to draw a scaled picture representation of the data, which means we're going to actually be drawing our pictograph. And then we're going to use our data or graph to answer some sort of question. Okay, so I'm going to jump right in and try mine. Now, mine is really meant to do with you in the classroom. So we're going to have to kind of look at this and come up with a plan because it says how many boys and girls are in your class. Well, we have a lot of third grade classrooms in our district and everyone's a little bit different. So we're just going to have to make them up right now. So gender of students in room blank. So I'm just going to say in room, and I don't think anyone has room 1. Maybe you do, but in room 1. Okay, so I'm going to show you what's a little bit tricky about sometimes these scales. So I'm going to pretend that in room 1 there are 28 third graders. So I'm going to say there's 28 third graders, but they want to know how many boys and girls. So I'm going to say there's 15 boys and 13 girls. Okay. And gender means, are you a boy or a girl? Or when you're a grown up, are you a man or a woman? So that's why our title is gender. Okay, now when I look at my scale though, they tell me that a happy face or a smiley face equals 2 students. So I'm not going to draw 15 happy faces under the boy because each one equals 2. So watch what's going to happen here. I'm going to draw 1, and that's 2 students. Now I have 2 and 2 is 4 students. 2, 2, 2, 6 students. 2, 2, 2, 2, 8 students. 10 students. 12 students. 14 students. Okay, now here's my problem. This equals 14 students, but I need to show I have 15. So if I drew another happy face, someone would think I had 16 students. So this scale of 2 doesn't work so great for my numbers, but I'm just kind of stuck with it. So watch what I can do. This is kind of silly. I can draw half of a smiley face, which means this is 2, 2, 2, 2, 2, 2, 2, and half of 2 would be 1. So I get 7 2s, which is 14, plus 1. That shows that I have my 15 boys. I would have to do something similar for my girls because watch what's going to happen. I have 2, 4, 6, 8, 10, 12, and I need to show 1 more girl, so I could draw half of a happy face, and that will show that that only represents half of 2, which is 1. So 6 2s is 12, plus 1 is 13. So the scale of 2 students didn't work so great for this specific problem. But you don't really get to choose how many students are in your class. Okay, so with that, I have some questions now to answer. It says, use the data from the scaled graph to compose and answer questions. So how many girls were in your class? Well, we had 13 girls. How many boys were in your class? 15. How many more girls than boys, or vice versa? Vice versa means the opposite. So it means for our graph, how many more boys than girls? So it means you could switch it. Well, there was 2 more boys than girls. And then it says, how would your graph change if the happy face represented 5 students instead of 2 students? So that's where this gets a little tricky because let's think, if I had to redo here's my boys and here's my girls, and they want to know if the key was happy face equals 5 students. Well, that's going to be really easy for my boys, but it's going to be really tricky for my girls because watch what happens with the boys. 5, another 5 is 10, and another 5 is 15. So for the boys, it worked out great. But look what happens when I do the girls. 5, 10, and I have 3 more girls. So how do I draw part of a happy face to do 3 girls? If I drew half of a happy face right now, what's half of 5 is 2.5. So it's hard to kind of show how I would draw this 3 more girls. I mean, I would have to draw some sort of face and have it not be complete, but I don't think that anyone's going to actually be able to figure out based on my I'm kind of missing some. I don't think anyone would really figure that out. So I think that that's how it changes, is I could say that it would be hard to represent, which represent means to show, so to represent the 13 girls. I think that that's what's going to change the most. It would be really hard to represent the 13 girls. Okay, so ladies and gentlemen, we're going to try some together on page 200. Now again, these are meant to do in your classroom, so we're going to have to kind of make them up as we go and just kind of put in some pretend numbers. So I realize these numbers are not quite accurate. And let's not really worry about it. Okay, ready? So fill in the chart for your class data. Okay, so I'm just going to fill in our class data. We're going to stick with our same pretend class of 28 third graders. And I'm going to say that 6 of them have favorite color of red. Okay, we have 10 have a favorite color of blue because that's a really popular color. Okay, then green, we have 7 favorites with green. Okay, and then we have 5 favorite yellow. And we're going to see the same problem that we've seen before with this scale idea. Okay, all right, so for our red, it says third grade's favorite colors, but let's pay close attention to our scale. Our scale is each check mark is going to equal 2 students. So for red, there's 6 students. So I could say that's going to be 2, 4, and 6. That was pretty easy to do. For blue, there needs to be 10 students. So we could say 2, 4, 6, 8, 10. Okay, now watch what happens when we hit the green, because the green and the yellow, these are going to be our tricky ones right here. This is going to be where the scale is not going to work so nice for us. Okay, ready? So 7. So we have 2, 4, 6, and then how do you draw half of a check mark? So that's where it gets really kind of hard. So we could maybe draw like something like that, but I don't think that this is very clear to someone reading the graph. So this scale is not working so well for our data. And for yellow, we would have to do 2, 4, and then again, we need to show 1 more person, not 2, so we might need to draw like somehow like half of it. But scales work really good sometimes and not really good other times. Okay, let's answer some of our questions. Okay, how many students preferred red? So they would want us to use our graph to answer that. So red was easy to read because red was just 2, 4, 6. And this time our question says, how would your graph change if your check mark represented 1 student instead of 2 students? Well, we would obviously need a lot more check marks. So we would need more check marks. Okay, but here's the good thing is it would have been easier to show how many students liked yellow and green. It would have been. We wouldn't have to worry about those like half check marks. that's kind of the part that made it tricky, was those half check marks. Okay, so boys and girls, yours today, you don't need to make up data because they actually give you some data. So you just have one graph to finish and then one set of questions. Have a nice afternoon.